What if I told you that a truck engine designed to haul hay bales ended up humiliating Ferrari at Le Mans? Not some exotic race-bred power plant with titanium this and carbon fiber that. A cast-iron workhorse that Ford engineers pulled from their commercial vehicle catalog. This is the story of how the Ford FE engine went from moving America's freight to crushing European racing royalty at 200 miles per hour for 24 straight hours. Picture this. It's June 1966 at the Circuit de la Sarthe. The French crowd is expecting another Ferrari coronation. Instead, they witness 3 Ford GT40s crossing the finish line in perfect formation. Under the hood of each one, a descendant of an engine that started life in 1958 F-Series pickups. The automotive establishment was scandalized. How did a pushrod V8 designed for dump trucks just embarrass the finest racing engines Europe could produce? The Ford FE wasn't supposed to be a legend. It was supposed to be dependable. When Ford introduced this engine family in 1958, they needed something that could handle the abuse of commercial use, construction sites, farm work, towing, the kind of thankless jobs that kill fancy engines, so they built it like a bank vault. In 1958, America was in the middle of an economic boom. Eisenhower's interstate highway system was under construction. Suburban sprawl demanded reliable vehicles for contractors and tradesmen. Ford's Y-block engine, their previous workhorse, was showing its age. It couldn't handle the increased loads and higher speeds of modern highways. The company needed something completely new, something overbuilt. Ford's engineers started with a clean sheet. They called it FE for Ford Edsel. Yes, that Edsel. The marketing disaster that lost Ford $350 million. But while the Edsel brand crashed and burned, its engine architecture would become one of Ford's greatest triumphs. The irony wasn't lost on anyone. The original FE engines displaced between 332 and 352 cubic inches. Nothing exotic about the specifications. Overhead valves, pushrod actuation, cast-iron construction. The innovation was in the details that nobody talked about in marketing brochures. The deep skirt block design extended the cylinder walls well below the crankshaft centerline. This created an incredibly rigid structure that resisted flexing under load. The main bearing caps were cross-bolted, held in place with both vertical and horizontal bolts. Overkill for a street engine, essential for what was coming. But here's where it gets interesting. While GM and Chrysler were chasing horsepower with bigger and bigger engines, Ford's engineers noticed something. The FE block could take enormous abuse without cracking. Taxi companies running 352 FEs reported 300,000-mile rebuilds with the original blocks still in perfect condition. Heavy-duty truck operators pushed them even harder. These engines just wouldn't die. By 1961, Ford expanded the FE family. The 390 cubic inch variant became the volume seller. In standard trim, it made 300 horsepower with a 4-barrel carburetor. Respectable, but not remarkable. The 401 pound-feet of torque was more impressive. This was an engine that made its power down low, perfect for accelerating 2-ton Galaxies away from stoplights. Nobody suspected it would soon be screaming at 7,000 RPM on the Mulsanne Straight. The transformation started in 1960 when Ford created the high-performance 390. They bumped compression from 9.61 to 10.61, added a hotter camshaft with more duration and overlap, installed an aluminum intake manifold. The result was 401 horsepower, briefly making it the most powerful engine Ford offered. But this was just the appetizer. Ford's Total Performance campaign kicked off in 1962. They were tired of GM dominating NASCAR, tired of being seen as the sensible choice while Chevrolet got all the glory. Henry Ford II wanted to win everything: drag racing, stock car racing, and most ambitiously, international endurance racing. The FE would be their weapon. The 406 cubic inch FE, arrived for 1962. This was serious hardware. The bore grew to 4.13 inches while keeping the 3.78-inch stroke. Triple two-barrel carburetors fed the beast. In top specification, it made 405 horsepower at 5,800 RPM. More importantly, it made that power reliably. While Chrysler's 413 Max Wedge was faster in the quarter mile, the 406 could run wide open for hours without overheating or scattering parts. NASCAR teams discovered something interesting about the FE architecture. The priority main oiling system sent oil to the crankshaft bearings before the cam or valve train. Under hard cornering or acceleration, other engines would starve their bottom ends of oil. The mains would spin and the engine would grenade. The FE just kept running. You could bang it off the rev limiter lap after lap, and it would ask for more. Then came 1963 and the 427. This was the FE pushed to its practical limit. Bore increased to 4.23 inches. Stroke stretched to 3.78 inches. In street trim with a single 4-barrel, it made 410 horsepower. With dual quads, 425. But Ford wasn't building this for street cars anymore. They had bigger plans. Carroll Shelby entered the picture. The Texas chicken farmer turned racing driver had been building Cobras with Ford's small block 289. Fast, but not fast enough to challenge Ferrari's prototype racers. He wanted the 427 FE. Ford gave him something better, the competition version with cross-bolted main caps, forged pistons, and a solid lifter cam. In the lightweight Cobra, it was devastating. 0 to 100 and back to 0 in under 14 seconds. But the real development was happening at Holman Moody's shop in Charlotte. John Holman and Ralph Moody were Ford's secret weapon. Officially, they were independent racers. Unofficially, they were Ford's racing development arm. They turned the 427 FE into something that could survive Le Mans. Le Mans wasn't like any other race. NASCAR races lasted 3 or 4 hours. Drag races lasted seconds. Le Mans was 24 hours of mechanical torture, full throttle down the Mulsanne Straight for nearly a minute, hard braking from 200 miles per hour. Repeat for an entire day. European constructors used complex, high-strung engines with overhead cams and exotic materials. Ford would beat them with pushrod simplicity and American iron. The first attempt came in 1964 with the GT40. Beautiful car, wrong engine. They used the small block 289. It was reliable but down on power compared to Ferrari's V12s. Ford managed some podium finishes, but no wins. They needed more displacement. They needed the 427. For 1965, Ford installed the 427 in the GT40 Mk2. But there were problems. The engine was too tall for the GT40's low roofline. Engineers had to use a special intake manifold and dry sump oiling system to reduce height. The dry sump alone added 50 pounds, but solved oil starvation issues during high G cornering, worth every ounce. The competition 427 was different from anything in Ford showrooms. The block was specially selected from production for its thick cylinder walls. Sonic testing ensured uniform thickness. The crank was forged steel instead of cast iron, cross-drilled for better oiling. The rods were forged steel with full floating pins. The pistons were forged aluminum with anti-friction coatings. The cylinder heads were the real magic. Ford created the medium riser heads specifically for endurance racing. The ports were raised for better flow, but not so much that low-end torque suffered. The valves were 2.19 inches on the intake, 1.71 on the exhaust. Sodium filled for better heat dissipation. The valve springs were good to 7,200 RPM, unheard of for a pushrod big block. But the master stroke was the side oiler block introduced in 1965. Instead of routing oil through the cam bearings to reach the mains, Ford cast a dedicated oil gallery along the side of the block. Oil pressure went directly to the main bearings first, then to the rods. The cam and valve train got whatever was left. It was the opposite of conventional thinking, and it worked brilliantly. Testing at Le Mans in 1965 revealed more problems. The engines were strong but thirsty. Fuel stops were killing lap times. Ford's engineers calculated they needed at least 480 horsepower to compete with Ferrari, but with better fuel economy. Impossible? Not for Holman Moody. They started with the camshaft. The Street 427 used a hydraulic cam with modest duration, fine for stoplight racing, useless at Le Mans. The race cam had 324 degrees of intake duration, 334 degrees exhaust. The overlap was enormous, 108 degrees. At idle, it sounded like the engine was dying. At 6,000 RPM, it sang. The compression ratio went up to 12.1. Street engines ran 10.5.1 or 11.1 to survive on pump gas. The race motors needed 115-octane aviation fuel. The carburetors were specially calibrated 780 CFM Holleys, 4 of them on tunnel ram manifolds. Each carburetor fed 2 cylinders directly for instantaneous throttle response. Here's the thing about endurance racing. Power is worthless if the engine explodes after 3 hours. Ferrari learned this repeatedly. Their sophisticated V12s made beautiful noises and impressive dyno numbers, but frequently scattered their internals across French countryside. Ford took the opposite approach. Build it strong, then make it fast. The 427's bottom end was designed for 7,000 RPM continuous operation. Let that sink in for a moment. 7,000 revolutions per minute for 24 hours. That's 10 million revolutions, each piston traveling up and down 20 million times. The forces involved were staggering. At peak RPM, each piston experienced 2,000 Gs of acceleration at top dead center. The connecting rods were the weak link in most engines. Under extreme RPM, they stretched like taffy. When they finally let go, they punched holes through blocks and oil pans. Ford's solution was elegant. They used longer rods, 6.49 inches center to center. This reduced the rod angle, decreasing side loading on the cylinder walls. Less friction, less wear, less chance of failure. The oiling system was completely reworked. The standard FE oil pump was good for 60 psi. The race version delivered 100 psi hot. Oil capacity increased from 5 quarts to 12 with the dry sump system. External oil coolers kept temperatures below 260 degrees even in summer heat. Every bearing surface was micro-polished. Every oil passage was deburred and radiused. Cooling was equally critical. The standard 427 ran a 180-degree thermostat. The race engines used 160-degree units with high-flow water pumps. The radiators were enormous, nearly twice the surface area of street versions. Air ducting was carefully designed to extract maximum cooling with minimum drag. The engines ran between 180 and 200 degrees no matter how hard they were pushed. Now here's the kicker. While Ford was spending millions developing the 427 for Le Mans, they were simultaneously selling it to the public. The 427 Galaxy, the 427 Fairlane, the 427 Cobra, each one a slightly detuned version of a Le Mans winner. Customers had no idea they were buying race-proven technology. The 1966 Le Mans race would be the ultimate test. Ford entered 8 GT40 Mk2s with 427 power. Ferrari brought their new 330 P3 with a 4-liter V12. On paper, the Ferrari was superior. Overhead cams, 4 valves per cylinder, 420 horsepower from 242 cubic inches. The Ford was a brute. 427 cubic inches, making 485 horsepower, but weighing 200 pounds more. Practice revealed the Ford's advantage. The 427's massive torque meant drivers could use taller gearing, fewer shifts, less stress on the transmission. The broad power band meant they could be lazy with their shift points and still run competitive lap times. The Ferraris had to be driven perfectly. The Fords were fast, even when driven badly. The race started at 4 p.m. on June 18th. By midnight, half the field was out. Blown engines, crashed cars, mechanical failures. The Fords circulated like clockwork. Hour after hour, lap after lap, The Ford 27s never missed a beat. The side-oiler design was proving its worth. While competitors lost engines to bearing failure, the Fords just kept running. By dawn it was clear Ford would win. The question was, which car? 3 GT40s were running in formation, all powered by 427s, built in the same Holman Moody shop. Ford executives wanted a photo finish, all 3 cars crossing together. Racing purists were horrified. You don't orchestrate Le Mans victories. Bruce McLaren and Chris Amon won in the number 2 car. Ken Miles and Denny Hume were second. Ronnie Bucknam and Dick Hutcherson third. Ford had done it. They'd beaten Ferrari at their own game with an engine designed for trucks. The French crowd couldn't believe it. How did pushrod technology from the 1950s just destroy Europe's finest engineering? But wait, there's more. Ford wasn't satisfied with just winning. They wanted to dominate. For 1967, they developed the Ford 27 even further. The MK4 GT40 used an all-aluminum version of the Ford 27, same basic architecture, but 100 pounds lighter. It made 500 horsepower and could rev to 7,500 RPM. It won Le Mans again. The technology developed for Le Mans trickled down to street engines. The side-oiler block became available in production cars. The medium riser heads could be bought over the counter. The forged bottom-end components were optional on 427 Cobras. Customers were literally buying Le Mans-winning technology. The 427 SOHC was Ford's ultimate expression of FE potential. Single overhead cam per bank, 657 horsepower in race trim. It was banned from NASCAR before it ever raced. Too powerful, they said, too advanced. Bill France didn't want Ford dominating his series. The SOHC became mythical, the engine so good it was illegal. By 1968, the FE's racing days were numbered. Ford developed the 385 series engines, what would become the 429 and 460. More modern design, better breathing, lighter weight. But they never matched the FE's reputation for indestructibility. When you needed an engine to run wide open for 24 hours, you built an FE. The numbers tell the story. Between 1958 and 1976, Ford produced over 8 million FE engines. From 220 horsepower truck motors to 657 horsepower racing monsters, the same basic architecture, the same deep skirt block, the same cross-bolted mains. What started as agricultural equipment became racing royalty. Think about that for a second. Ferrari spent millions developing bespoke racing engines, exotic materials, cutting-edge design, hand assembly. Ford took their truck motor, made it angry, and won Le Mans twice. Then sold versions to the public that could pass emissions testing. That's not just engineering, that's alchemy. The FE's influence extends beyond Ford. The Boss 429 borrowed its cross-bolted main design. Chevrolet's Mark IV Big Block copied the Priority main oiling. Chrysler's 440 six-pack used similar port layouts to the medium riser heads. Everyone learned from the FE's success. Modern engines make the FE look primitive. Variable valve timing, direct injection, turbocharging. A new Ford EcoBoost makes more power per cubic inch than any FE ever could. But there's something about the mechanical simplicity of the FE that resonates. No computers, no sensors, just iron, aluminum, and gasoline combining to make violence. So what was actually the secret? Why could the FE survive what killed other engines? It wasn't one thing. It was the accumulation of small improvements. Better oiling here, stronger rods there, improved cooling passages, better valve train geometry. Each change was incremental. Together, they created something revolutionary. The side-oiler system alone was genius. Most engines oil the valve train first because it's at the top, easy to reach. The oil then works its way down to the crank. By then, it's hot, aerated, and contaminated. The FE reversed this. Fresh, cool oil went straight to the mains. The bottom end got priority. The valve train survived on leftovers. Backwards thinking that worked. The deep skirt design was equally important. Most engines ended their cylinder walls at the crank centerline. Weight savings. The FE extended its cylinders inches below the crank. Extra weight, but incredible rigidity. The block didn't flex under load. Bearing clearances stayed consistent. Cylinder bores didn't distort. Everything stayed where engineers put it. Cross-bolted mains were overkill for street use. A standard FE with 2-bolt mains could handle 500 horsepower. But at Le Mans, engines experienced massive G-forces in corners. The crank tried to walk sideways in the block. Cross-bolts prevented this. They turned the lower end into a solid unit. The crank couldn't move if it wanted to. The FE's bore spacing was generous, 4.63 inches. This allowed for larger valves and better port angles than competitors. It also meant thick cylinder walls even at maximum bore. A 427 could be bored 0.030 over without issues. Try that with a Chrysler 440 and you'd have cooling problems. The FE just got angrier. But here's the real genius. Ford didn't try to make the FE exotic. They kept it simple. Push rods instead of overhead cams, 2 valves instead of 4, cast iron instead of aluminum. Every complication they avoided was one less thing to break at 3 a.m. on the Mulsanne Straight. Today, original 427 FEs are worth fortunes. A genuine side oiler block sells for $10,000. Complete race engines trade for 6 figures. Collectors pay millions for cars with matching numbers Ford 27s. The truck engine nobody wanted became the most valuable American V8 ever made. The FE's legacy lives on in Ford Performance's current engines. The Godzilla 7.3-liter truck engine uses similar design philosophy, simple pushrod design, overbuilt bottom end, priority oiling. It makes 430 horsepower naturally aspirated and can handle 1,000 with boost. The FE would be proud. Racing improves the breed, they say. The FE proves it. Every taxi driver running a 390 Galaxy benefited from Le Mans development. Every contractor hauling lumber in an F-250 had race-proven reliability. Every street racer with a 427 Fairlane owned a piece of motorsport history. Ford didn't just win races, they made better engines for everyone. The lesson of the FE is profound. You don't need exotic technology to win. You need good engineering applied correctly. You need to understand your weaknesses and address them. You need to test relentlessly and learn from failures. Most importantly, you need to remember that reliability beats horsepower when the race is 24 hours long. In an era of overhead cams and multi-valve heads, the FE was already obsolete. It didn't care. It just kept winning. While competitors chased theoretical advantages, Ford perfected proven technology. They took a pickup truck engine and made it a legend. Not through revolution, but through relentless evolution. That's the American way, isn't it? Take something ordinary and make it extraordinary through sheer determination. Don't apologize for using old technology if it works. Don't chase complexity when simplicity suffices. Build it strong, make it fast, and let the stopwatch silence the critics. The Ford FE shocked everyone because nobody expected greatness from a truck engine. It was supposed to haul hay and pull trailers. Instead, it humiliated Europe's finest at their own game. It proved that with enough development, anything can become legendary, even a motor that started life in a 1958 F100. What's the most unlikely engine success story you know? Drop a comment below and share your thoughts on the FE's incredible journey from farm fields to Le Mans glory. And if you enjoyed this deep dive into one of Ford's greatest engines, make sure to subscribe because we're just getting started with these legendary motor stories.